Let's find the volume of the solid of revolution obtained by rotating the region bounded by the graph of the line y equals x plus 1, the x-axis for x between 0 and 3 as this region is rotated about the x-axis. The graph of this region is not difficult, and then from there we can find the nice picture of the solid of revolution that it generates. We draw the part of the line y equals x plus 1 in the first quadrant up to x equals to 3. So the region we are going to rotate is this region right over here. It's below the line y equals x plus 1, above the x-axis for the interval x between 0 and 3. 180 degree into the rotation, the region ends up here in the fourth quadrant, and then a full 360 degree rotation is going to give us the following solid of revolution. So it looks something like this. This is a rough sketch. You can think of it as a stack of pancakes, or pancakes that are stacked side by side. The smaller ones are closer to the y-axis. As we move to the right toward the line x equals to 3, the pancakes get larger. So what we're going to do is use a technique called the disk method to find the volume of the solid of revolution. The way it works is draw this region once again. This is x equal to 3. This is a line y equals x plus 1. And now pick any x between 0 and 3. This represents a typical x that could be anywhere closer to 0 or closer to 3, anywhere in between. Now we're going to take an interval, a small interval that contains x. The interval will have length delta x. So delta x stands for the length of I'll put small in parentheses because small, there's no such definition of what exactly small means. Just a tiny interval that contains x. The length of a small interval that contains x. And we're going to track a vertical piece of the area that looks something like this as it rotates 360 degrees. As you can see, it's going to generate a disk that looks like that. The radius of this disk is the y-coordinate of this point on the line, y equals to x plus 1. So let's take this disk and put it sideways. We can examine it further. It looks like a coin, or as I said earlier, a pancake. Its radius here is y, and this is the length of our interval that contains x. We define it as delta x. Delta V is going to be the volume of the part of the solid that's taken up by this small pancake, one of the pancakes that makes up the solid. So delta V equals pi times the radius of the cylinder squared times the thickness, which is delta x. And if we write it as a function of x, remember y equals x plus 1, so this is pi times x plus 1 squared times delta x. And then the volume is equal to, that's when we use the definite integral, from 0 to 3 pi times x plus 1 squared, and we replace delta x with dx. That's the notation in integration. The integral itself is very simple. The integral of x plus 1 squared is just 1/3 x plus 1 cubed. So this is pi over 3 times x plus 1 cubed, evaluated from 0 to 3. And if we plug in 3, we get 4 cubed, which is 64. So it's pi over 3 times 64 minus, when we plug in 0, we get 1. 63 over 3 is 21. Pi is the answer. 21 pi units cubed is the volume of this solid. Now we can find this volume by another method, non-calculus method, if we wished. Unfortunately, this doesn't work for many solids of revolution, and so we need to use the disk method whenever other methods don't work. Let me once again draw this region, so kind of a rough sketch, and then from the region we go right to the solid. Here's a solid. If I extend the line down to the x-axis, this is a line y equals x plus 1, it intersects the x-axis at -1. So it intersects it at x equals -1, and then this is 3. So our solid can be obtained. So solid equals big cone minus little cone, or small cone. If you think about it, the big cone is everything. The small cone is from -1 up to the y-axis, and then once we throw that out, that leaves us with a solid. Now the volume of the big cone is 1/3 pi times its radius squared times its height. The radius of the big cone is from here to here. We plug in 3 into the line x plus 1, we get 4. So it's 1/3 pi times radius squared times the height. The height of the big cone is the distance from -1 to 3, that's also 4. And then minus the small cone, 1/3 pi, its radius. We plug 0 into x plus 1, we get 1. So it's 1/3 pi 1 squared, and its height is from -1 to 0, that's also 1. This is equal to 64 pi over 3 minus pi over 3. It's 63 pi over 3, which is 21 pi, the same answer that we got before. For more videos, visit